Good day to all. Today I'm presenting for our group assignment for subject DENG 2223 Fundamental Electric and Microprocessor. We are group 1 from section 4. In this assignment, we are required to build a simulation circuit using Tinkercad software. The output should consist of 4 LEDs performing a simple running light coupled with a buzzer. The requirement of this assignment are as follows. When switch A is 0 and switch B is 0, all the output should be off, which means all the LEDs should be off. When switch A is 0 and switch B is 1, the LED should run from left to right. When switch A is 1 and switch B is 0, the LED should run from right to left. When both switch A and switch B are 1, the buzzer is on. This is the circuit we constructed on Tinkercad software that fulfill all the requirements of the assignment. When the slide switch to left, the output is 1 and the output is 0 when switch to right. I'll start the simulation now. As we can see, when both switch A and B are 0, all the LED are off. When switch A is 1 and switch B is 0, the LED running from right to left. When switch A is 0 and switch B is 1, the LED running from left to right. When both switch A and B are 1, the buzzer on. This has fulfilled all the requirements of the assignment.
Good day to all. As you can see, one of my groupmate Chong have already presented on his part on the requirements which have to be fulfilled and how the circuit works. Well, today I'll be presenting on how our circuit works technically. Okay, as you can see here, we have created a running light pattern with 4 LEDs and we have also incorporated it with a buzzer. So how do we do this is by employing the JK flip-flops and also 3 inputs AND gate. Okay, as you can see here, the output of the first JK flip-flop labeled as QX is connected to the clock of the second JK flip-flop. So by doing this, we get to form a negative edge-triggered 2-bit asynchronous counter. So this negative edge-triggered 2-bit asynchronous counter has a characteristic of a repetitive sequence. So this repetitive sequence enables us to run the light from right to left or left to right when the switch is operated. As you can see here, we have used resistor. So the resistor is used to limit the current flow through the LED and to prevent excess current, which can damage the LED. As you can see, we have also used diode. The diode used in the circuit is to allow current to flow only in one direction, and also to prevent reverse flow of current, which will eventually damage other electrical components. Okay, as you can see here, for the first 3 inputs AND gate, each 3 inputs were connected to the switch B output QX complement and also QY complement of the JK flip-flop. Okay, the output of the first AND gate is connected to the diode and then to LED 1. Okay, for the second 3 input AND gate, okay, its 3 input is connected to the switch B, QX and QY complement of the JK flip-flop. Okay, the output of the second AND gate is connected to the diode and then to LED 2. Okay, for the third 3 input AND gate, the 3 input are connected to switch B, output QX complement and also QY of the JK flip-flop. Okay, the output of the third AND gate is connected to the diode and then to LED 3. Okay, for the final AND gate, the 3 input is connected to switch B, output QX and output QY of the JK flip-flop. Okay, the output of the fourth AND gate is connected to the diode and then to LED 4. Okay, we also have a 1K ohm resistor which was connected to each of the LED. Okay, by doing this, we get to create the LED running effect, which the LED will now repeatedly run from left to right when the switch A is 0 and switch B is 1. Okay, to enable the LED to run from right to left, we have used a similar concept but on the opposite way, where the first AND gate is connected to the diode and LED 4. The second AND gate is connected to the diode and then to LED 3. The third AND gate is connected to diode and then LED 2. And finally, the fourth AND gate was connected to diode and then LED 1. Okay, by doing so, we get to create the LED running effect from right to left when switch A is 1 and switch B is 0. It's just the same thing, but in opposite way. We will continue with the activation of the buzzer. So you can see here, switch A and B is connected to a 2-input AND gate. So when both switches is 1, the buzzer will be activated. Well, that is the presentation from our group. Thank you.